Can you imagine the world without satellites? They're so much a part of our daily lives, and yet they've only been in existence for a little over 40 years. Early satellites were launched to observe weather and for navigation, but today they're used for everything from entertainment, education, research, tracking endangered species, to helping us find our way when we're lost. Satellites are made of 4 major components: a control base, communication capabilities with Earth, a power source, and observing instruments. Messages sent to the satellite from the control base are called uplinks, and messages transmitted from the satellite back to the Earth are downlinks. Most satellites are battery-powered and rely on the sun to recharge their batteries through large solar panels. Specialized instruments or sensors on a satellite gather data that are used by scientists. The sensors are capable of gathering a wide range of information about the Earth's atmosphere, land, and oceans. Not all satellites view visible light. Depending on the mission, measurements might be taken in the visible light range, microwave, radar, or infrared range. Some satellites don't even face the Earth, but are used to study the Sun, which provides almost all of the energy for our Earth system. Satellites transmit digital data to a computer on Earth, which translates the data into a useful form. Sometimes the data takes the form of a photographic image. Often satellite images are color enhanced to make certain details stand out. Weather and communication satellites are positioned at a point 22,238 miles above the Earth's equator in what is called a geostationary Earth orbit. In 1945, science fiction author Arthur C. Clarke suggested that satellites placed at this altitude would rotate around the Earth in one day. Since a satellite placed at this altitude takes the same time to complete one revolution as the Earth rotates once, the satellite appears stationary above the Earth. That's why satellite dishes on the ground don't need adjusting once they've been aimed correctly at the target satellite. An added benefit for weather satellites is that at this altitude, the satellites get a full disk view of the Earth. Because they stay above a fixed spot on the surface, they provide a constant vigil for the atmospheric triggers for severe weather conditions such as tornadoes, flash floods, hailstorms, and hurricanes. Other satellites orbit the Earth in less time. As these satellites pass over different locations on the Earth, they take measurements that paint a picture of the patterns over the entire globe. The difference between a geostationary and an orbiting satellite is the difference between seeing one point on the Earth all the time compared to seeing the entire Earth over a long period of time from closer up. Scientists study the Earth using both geostationary and orbiting satellites. Satellites, an essential tool for viewing our home. They look down on us from space. But guess what? It's a two-way street, so to speak. On a clear night, especially near dawn or dusk, check out how many orbiting satellites you can see in the sky. Even though you're in darkness, a satellite passing overhead may still be in sunlight. Light reflecting off the satellite may be bright enough to illuminate the satellite for us to see it as it passes overhead.